Hey everybody, it's Mike, and I'm here with a little bit of homework help. This question came in. Use the graph of the polynomial function to solve the inequality. And the inequality that we have is 4x cubed plus 17x squared is greater than or equal to 44x plus 12. And you'll notice that down here we have f of x is equal to 4x cubed plus 17x squared minus 44x minus 12. So that's our cue that what we want to do is we want to get this equal to 0, and we're going to do that by subtracting 44x and subtracting 12 from both sides. So what we'll end up with is 4x cubed plus 17x squared minus 44x minus 12 is greater than or equal to 0. Okay, and that's our graph, and we're looking for it to be greater than 0. So I'm going to take a look, and you'd be able to zoom in and confirm this. Right here it looks like this point at 1, 2, 3, 4, 5, 6. So negative 6 is at 0. So that's my first boundary point, is negative 6. And then I've got the one that was listed, negative 1/4. And then I've got this one at 1, 2, at 2. And those are my 3 boundary points. And what I could do is I could take and pull up a calculator here. And I could take my calculator and say, let's take negative 6 and let's store that as x. And then we're going to do 4x cubed plus 17x squared minus 44x minus 12, and we'll see what we get. Hey, great, we get 0. And then I'm going to take 2. I'm going to store that as x. And I'm going to do the same entry again. And that's 0. And I've just confirmed that those are indeed the boundary points. That's where it's 0. That's where it switches from positive to negative. So that means in this region it's positive. This curve is greater than 0. And then in this region the curve is greater than 0. So that means that our boundary is starting at negative 6, and then it goes to negative 1/4, and then it also switches over at 2, and then it just keeps going greater than 0, so to infinity. And I want to union those two pieces of the boundary. And notice that I'm using the, let's fix this, make it look pretty. I'm using the square brackets right here, and this is a closed set, this is a closed set, because we have the equal to, here. It's greater than or equal to, and because of that we're using these squared off hard closed square brackets. Okay, I hope that helps, and I will see you next time.